All right, now, let's take a quick moment to talk about a couple of rules. First, product rule. Now, I'm not going to say you need to know the justification behind it. All right. Earlier, I explained to you how these derivatives come to being, right? But I'm going to say for product rule, don't worry about how it comes to being. If you're interested, fine, go ahead, find it out. But I'm not going to chase dig deep on the background of it. So the presentation right here is that if you have a function that is a result of two separate functions, such as this, okay, such as this. If I say h of x, it's equal to e to the x times sine of x, for example. All right, can you see how they're multiplying together? If you can see it, then we say, oh, since they are multiplying, right, then we must execute this so-called product rule. So how does it work? It works pretty easily. That it's a sum of two parts. So the two part is basically taking the derivative one at a time, finding the derivative one at a time. And it doesn't matter which one you do first, as long as you tell yourself it's never going to be two functions being the derivatives at the same time. Okay, it's only one being derived, not both. Okay, and then they take turn, and you add them all together. You add them up all together. So right here we'll say, oh, what's this then? So if you derive by the first one, you say, oh, the derivative of e to the x is, well, lovely, e to the x. And then the second function is unchanged. And then you add e to the x, that is the original e to the x. And then you differentiate differentiate sine x, and you get cosine of x. And of course, since they both have e to the x, you would go ahead and factor it out to make it look nicer. So this question right here, when we try to practice our product rule. So again, like I said, can you see the two so-called functions? All right, can you see the two things you are multiplying with each other? And if you do see it, then it will qualify you to use the product rule. And we say what? Oh, just go ahead, take the derivative one at a time so that you can get the overall derivative. So my first question here is that did you write this on your paper? If you did not, it's a crime. Because if you don't write this, what I can imply based on your notation is that you are transforming g of x, and I have no idea how these two parentheses all of a sudden becomes two things being added together. Right? So I hope you understand why I care about this notation so much. And then we say, all right, the derivative of the first, and I'm going to use my green color right here to represent the derivative of the first, and then keep the second the same, and then the first function times the derivative of the second. All right. Now, here's the next question, and the next question is how much of a simplification you should do. Now, there are the short answer is that if you could foresee something to be canceled out, something to be eliminated or combined, then you should go ahead and factor them or combine them. Now, for this one, what catches your attention here? Anything that catches your attention? Oh, whoa. Yeah, thank you. Thank you for catching it. 2x minus 4, yes. So yes, you would also need to use the power rule in this case, which you learned previously. 2x minus 4. So if I were to go ahead and simplify this, I would say, yeah, go ahead, expand it, distribute it. Okay, and for the second half, and yes, you would have to do FOIL. All right, you would have to do FOIL. And you just combine your like terms. All right, combine your like terms. All right, so that gives you a total of 4x cubes, okay? And then minus 12x squared plus 6x minus 12. And if you can produce something like this, I would say we're very happy, and you can just leave it like this. We probably would not ask you to say, could you go ahead and factor out the 2 out of all these numbers? Yeah, save it. This is good. All right. All right, now keep going. We'll just do one more product rule problem. That would be the next question, and that is, yeah, the next question. Just say f of t, for example. F of t is equal to square root of t times 1 minus t squared. Okay, so like I said, can you see the two functions? All right, can you see the two functions? If you think putting a dot in between them would help you see it better, go ahead, help yourself, okay? It's not a must, but if you want to do it, not a problem. So again, you're trying to differentiate it. So, so the derivative of the first one, and by the way, you may want to do this before you start. Okay, you may want to do this before you start, and that is to rewrite the square root of t to the power of 1/2, so that you can do your power rule easier with greater confidence. Okay, oops, let me go ahead and change it to green so you can see it in a better view. And then we keep the second function the same, plus the first function right here. And then the, what is it called? Then we do the derivative of the second, which is negative 2t. All right, so now, is there anything that I would simplify? Well, maybe a little bit here. For the first term, I probably would do something like this. I would take care of the negative exponents. I think the instruction also sets no negative exponent or complex fraction. So for the first term, 1 minus t squared, stay in the numerator. It will stay in the numerator, and then 2 square root of t will be in the denominator. Second term, I am going to put the minus up front, and then the t square root t and the t would combine together to become t to the what power? 3 to the 3/2 power. Okay. This one? All right. Now, can you see? Well, this is the numerator, right? So it stays in the numerator. Now, can you see the 2 is a denominator? That's why the 2 is in the denominator. And then see the negative exponents right there? That means denominator. Okay. And I just revert the 1/2 power back to the square root. Okay. So now you got to be very fluent. When I taught pre-calc, when I share my when I talked about the exponential properties or exponent properties, I said this. I said that when you go to calculus, these exponent properties will be your daily diet. You use these properties every single day from now on, because you now know how to use power rule, and we are going to combine like terms like this every single day. So get used to it. Okay. 1/2 power means square root, and there's a negative, you make it into the denominator. Are we good? Yes. All right. Now, if we are good, then let's go ahead and switch gear to talk about quotient rule.